So in the previous videos, we started creating a chess board game, and in the last video, we created the available movements method for the model to figure out the positions where a piece can move in a specific position. So now I wanted to implement to put placeholders here. Indicating where we can move a specific piece. So I'm going to do that now. We are going to let's say place a solid rect of green but with alpha 0.5, or well, that's green for now. This is going to be this size, and we are going to place it for its movement. We are going to place it in the movement X, movement Y. Actually, let's use size and size vector to this movement is a point in. Okay, let's convert it to a float and then use size. Okay, so these are valid positions. Okay, so the thing is, we are not clearing all those rectangles, so let's create a placeholder container here, and let's use this container to place those rectangles. And before updating them, we are going to remove all the children. Remove children. So now we have all these positions. Let's set the alpha here, so it is not that okay, something like this, I guess. Okay, so for now let's keep it like this, and then let's implement other pieces. Let's place also a bishop near the knight, and now let's implement the bishop. Available movement. Okay, so this is the bishop. The bishop is going to be able to move in the diagonals as long as it doesn't collides with any piece. So let's implement this. Let's do as much. In the case the piece would be here, we would move like 1, 2, 3, 4, 5, 6, 7 positions. So we are going to make let's actually build a list that is going to be simpler. So in 0 until 7, in 4 kind of directions. So we are going to go to the top left, to the right, to the top right, to the bottom left, and to the bottom right. So these are the directions. So we are going to get the current position and the direction multiplied by this, I guess, float. So this could be we are getting some kind of exception. I missed X direction. Why is this one? I think I missed this. Now it works. So this looks fine, but it isn't, because if there is a piece here, let's place a piece there. So in the 2, 3, I guess, let's put a pawn. This position shouldn't be valid, and this is because we should like start skipping as long as this position is empty. So if it's not empty, sorry. So this new pose is empty, and this board is an empty, just all empty. Let's break. Sorry, it's not empty. Why? The direction. Because we start not in the 0 but in the 1. So we start from 1 to 7, I guess, then, including 7, because here 1, 2, 3, 4, 5, 6, 7, from 1 to 7. Okay, so this is the bishop movement, I guess. Okay, so yeah, this is the bishop movement. Now let's try something else. Let's move the pawn here, and now let's implement the pawn movement. The pawn movement is simple, yet it depends on the color of the piece. So for example, black's goes downwards in this case, and white's upwards. And in the case the pawn is in its initial position, like here, it's going to be able to move 1 or 2 positions, while if it is in another position, it is only going to be able to move 1 position. So let's implement that logic. So for example, here we have 2 positions. Let's say the direction is going to be determined by this piece plier. If the piece plier is white, it is the direction is going to be 0 minus 1, and in the case it's black, plus 1. Let's make it explicit. Let's make it explicit like this. So the direction is going to be we can try to add the position plus the direction. So this is the normal movement, but in the case the piece is in its initial position, it's going to be able to move 2 positions. So for example, the initial position is if the position is 1 for the case of blacks, and 6 in the case of whites. So in the case we are in the initial position, we are going to be able to move 2 positions. Like this. Here we are, this function, the valid empty position, is validating that we are not in a specific piece, and this seems to be working. Okay, so yeah, I think this is it. So yeah, let's stop here and continue in the next video. In the next video we will implement the remaining pieces movement, and we'll add the tests. Since we are actually previewing this in real time, we are not doing the tests manually, but we should. So let's figure out that later. So see you in the next video.